Hi there. Have you ever had the situation that your boss or your professor came to you with a lot of data and you should process them or you should analyze them? So here you see lists of numbers on my screen and I have to do that work. And therefore, it's quite good if you have solutions. You can do it manually, for example, with Excel, step by step in the tables, or you try to find other solutions. And for these other solutions, it's quite good if you're able to program code. And therefore, you can improve tasks, or you can do the same tasks each time you need it. And therefore, it's the first lesson, basics about programming, and especially basics about Matlab. So welcome. So welcome to the first lesson about Matlab. I split the lecture into two parts. The first part is the interactive use, where we will learn how to deal with the environment of Matlab with the first functions. So we will directly enter the commands to the Matlab command window and we'll see what happens. And then in the next lesson, we'll go into a more programming like version of Matlab. So we'll write scripts and functions, and then we will use these functions. So, but now let's start with Matlab. I will touch the three things. So you'll see what is Matlab. So what did MathWorks produce that you can have such an environment, and then we'll talk about the basics here. So constants, variables, which are matrices, and then we'll have a look into special functions offered by Matlab so that you can plot things or that you can calculate and do first nice steps to process your data. What is Matlab? So first of all, if you have any questions about Matlab, it's always quite good if you search the internet. So there are some reference documents like the Matlab primer. Then there are help pages on MathWorks homepage. There are a lot of forums and discussion reports on the internet. If you search Google, you will find a lot of them. And if you have then an idea what you need, then it's also quite good to go into the Matlab help, which is installed directly on your environment. I would also suggest to do this always in this way, that you first of all search the internet, because usually if you start with programming, you don't know exactly how this function is named or what you need, and therefore it's in most cases the best situation if you directly search the internet, and then if you have an idea how the function is named or which functions might work for you, then go to the help pages. So the help pages can be found here with the command help in Matlab, or you will find it if I show it to you here with this help question mark. So this is always a way if you have starting questions, and then you can follow this situation. So what is Matlab? Matlab is in principle interpreter language combined with an environment. So you have a language which is focused on mathematic methods and on numerical computation. And the nice thing is that you can directly use a huge set of graphical visualization tools, and you have a lot of toolboxes available. Important is that Matlab stands for Matrix Laboratory. So therefore, everything what you have in Matlab is based on matrices. Scalar, for example, is a 1x1 matrix. So everything is based on these multidimensional arrays, and they are treated as matrices. And another thing which is quite important is that, different to other languages, arrays or indexes of arrays start with 1 and not with 0. So usually, like in C or C++, the first element is indexed with 0. Here in Matlab, you start with 1. And all operations, so all operators, are in a main use based on matrix operations. So if you use a multiplication sign, then it's a matrix multiplication. So it's very, very related to these matrix laboratory things. The nice thing is that Matlab is an interpreter language, therefore it is very interactive, so you can directly enter commands in the command window, and it's focused on mathematical problems, so therefore mathematical expressions are very central in this software environment. So Matlab offers a lot of things. So it's a user-friendly syntax. So it means that, for example, you can use the mathematical expressions, mathematical representations. So it's quite user-friendly, and you have a lot of toolboxes available. So we now just use the standard version of Matlab. But if you need it for other tasks, for your studies or for other things, you have toolboxes for simulation, for image processing, for neural networks, for signal processing, for statistics, a lot of things which you can additionally install and which is already part of the campus license. And then you can play with complex and real numbers, so everything what you need, what you know from math is available. And of course also the symbolic computation. So you can use normal equation styles, and this can be extended with a symbolic math toolbox. So what you normally do with Matlab is prototyping or simulation, because it's quite ideal for that. So you directly get results, you directly see what happens, and you can write real fast programs for image processing and things like that. It deals quite nice with these graphical outputs, so you have from 2 to 3 dimensions. You have nice animation possibilities, all of this stuff. We'll focus on the basics in this course, but there are a lot of more. And then you have all of the basic functions which you know from math, like max, min, mean, inversion of matrices, or also sine, cosine, sum, all of these things already available in the basic version of Matlab. So you can directly do these calculations without any additional requirements. Matlab gives you also possibility to write your own application interface. Therefore, it's quite nice, and you have also possibility for Simulink, which helps you a lot for simulations. We won't touch these two things, we will use just the basics in MATLAB. So if you install MATLAB, then you will get this version available. You start MATLAB and you will get such an environment. This is a version of an older MATLAB, but it shows everything what you have. So you have basically a command window where you can enter commands. You will have the directory output where you see all of your programs which you have already written or which are available in your own workspace. Then you have the command history. All of the commands you have entered are there so that you can double click and restart the same command again or get it back to the command window. You have an own editor. If you click onto a variable in the workspace, you will get a table with all of the values which are stored there. So you have this workspace which shows the existing matrices at the moment, so the values you have created, for example, and then you have a tool which shows the current path. You can separate your programs to different locations, and if you want to call it without any path information, you can directly set the path here so that you can set up a hierarchical structure of your code. I want to show it with the version 2019. So version 2019 looks like this. So you have the menu bar here with all of the important menus. You have this current folder window, you have the workspace, you have the command window, and you have the command history. You can set this version of presentation so that you split into another splitting of the windows. So for example, if you don't want the command history, then you can kick it off and you just have the things you need. So for me, I really like this setup. So if I have the things available here, I directly see what is at the moment in the workspace, so what is at the moment in the memory for my program, and I also have the programs available here which I wrote, and I have the command history available. Here you can enter commands. So one example, display hello world. So, and then you directly see, if you start it, you directly see the output. So, if you deal with this, then it's quite helpful if you know special basics. So I made this window. I won't explain all of these things at the moment, so we'll come back to it again. But it's one overview page of this most important keyboard keys and commands. The keyboard keys you should know. So it's not so different to what you know from other programs, like getting the last line, getting the next line, or character back, character forward, or one word back, one word forward, home and end, and delete the line or delete the last character. So things which you also know from other editors. What is quite nice in some scripts is this long line continuation. So if you have very long mathematical expressions, then it's quite helpful if you don't have it in one line. And if you want to continue in the next line, so that one command should be continued in the next line, then it's quite helpful to use these dots here. So 3 dots mean go to the next line and continue the command there. So on the other hand, you have the workspace calls. Though all of these things are functions. I will explain later what functions are, especially in the second lesson of this course, so that you will see what the specific thing of functions are. But here, the main functions which you should know, you can call it without any parentheses. So the most important things are clear, close, and CLC, and in a special way, clear all, close all, and CLC. All programs which I write start with this commands, because what do they do? So if we have some variables in the workspace with clear all, you can really delete the complete memory. If you have a variable in the workspace, for example m and y, and you just want to delete one of these variables, then you can name this variable clear m, for example, will just delete this variable m. You see it here, that it directly deletes it. So clear m or clear y. So there you can select individual variables. These two individual selected variable deletion is quite important if you write scripts, and after the script a lot of variables stay, for example index counters or whatever. Then you should always clean up things which you won't need in the future anymore. So that in a workspace, after a script, in a workspace is only available what you really need after this script. Therefore, these clear things are quite important. And I always start my programs with clear all. So close all is the same, just for figures and external images. So you don't see here anything because I have no open windows. But you should always do a clear all and a close all if you start a new program, so that you have a very, let's say, virgin version of the workspace and the environment. And CLC is a cleanup of the command window, so that you start again at the beginning of the command window. So if you do these 3 commands at each program start, then you will have a real cleaned version of your Matlab. Nevertheless, you will have always the commands available in the command history. So what else do we need? So we have seen these 3 things. Later on we will use load and save. So if you want to load or save data to files, and then you can also show things which are in the workspace. So if you enter who and the variable name or whose, then you will see what is in the workspace. These functions are in principle necessary if you have not always the workspace open. Then you can use this. You can also do file operations. So if you create a file, you can of course delete the file with delete, and you can change the current directories. You can manipulate the current situations, and then you can also make a diary, so that, for example, things which you typed in will be stored in a separate file, so that if you start diary with a file name, then it starts the recording. So it's something like a logbook. It's sometimes quite helpful if you want to test first your program, or your input, and then you store it, and then you check it, and you just copy and paste things out of this. And then with diary off, you will have the switch off of the diary. So it means that you have a lot of possibilities here with the basic functions. And if you have questions about other functions, you can also call help or help desk, so that you will get information about further functionalities. So that's all about what you should know for a starting point with Matlab. So let's now come to the first small commands which we want to use. We want to focus on the basics, so constants, variables. Variables in this sense are matrices, and operations. So you have a lot of math constants available here. In principle, they deal with limitations or with things you know from other mathematical fields. So like pi, which is the ratio of the circle circumference to its diameter. If you enter pi, you get the full precision pi in double precision. And then the other functions which are quite important are int max, int min, which are the maximum and the minimum number which can be represented. The real max and real min, it's the maximum minimum number which can be represented in real. You also have epsilon. Epsilon is the floating point relative accuracy. In principle, this is the minimal distance between two floating point numbers. So this is the minimal representative fraction in a floating point number. And then you have I and j, which is the imaginary unit part. And you have two other things, infinite and not a number. So these are special classifiers which define infinite number or not a number. So not a number is often used in statistic sets to represent that there is no number available, or it will be also the result of a calculation, for example, division by 0 or something like that. So if I switch to Matlab, then I can enter these commands. So for example, if you just enter pi, then you get pi. You just see now 3.1416, but you should have in mind that there are at least 15 plus a few more places after the dot available, so that it's the full precision. And as I said, these constants are also functions, so you can call this also with the parentheses, and it will result in the same. So this is the normal official function call, and this is the single call without these parentheses. So pi brace open, brace close. So if you want to know what is the largest or the biggest number for integer representation, you can type int max, and then you will see that it is an int 32, and you will have this representation. The minimum int max, the minimum int representation is int min. So you see minus number here is the minimum representation, and the same is for real max and real min. And the epsilon, so the relative accuracy of floating points, is this. So with these things you have a lot of possibilities to limit, for example, counters, so that you have no carryover or overflow situation with this int max and int min things. or you can directly use the calculation with pi. Variables in Matlab are always matrices, and they have always a fixed data type. So usually you have double precision floating point numbers. But you can, of course, convert these data types to other data types. And therefore, for example, if you have to read binary files, then you have to know which data type is used for which value, and therefore you have to select the specific data type. And here are all of the data types which are available. So you have int32, which is the standard integer. You have this long int64, which is the long integer version. And you have it in the signed and unsigned version. So signed is always with plus minus range. Int32, for example, is with plus minus range. Unsigned int32 is just the positive range, so from 0 to positive numbers. You have also single bytes, so you can separate between a character, a single character element, or int8. So the difference is between letters based on the ASCII code. I will show later during the whole lessons what's the difference between ASCII and binary representation of numbers. Therefore, you have these two things, and you have also a logical value true and false available. So, variables are always matrices, also scalar variables, and therefore you create a matrix or a variable if you give it a name. Then you make a equal sign, so an assignment, and then you give a number or an array or a matrix. So here is one sample. So it shows, for example, that the name is num students. So the name must be unique. It's the identifier, and then it's equal 25. So it's a scalar assignment. So we can directly do it here. So let's clean the screen again, CLC, you remember. And then we enter num students equal 25. So there are now two differences. If you enter a semicolon, then you won't see the next line. So I do it here in comparison. If you don't enter a semicolon like in the first here, then the processing step or the result of this processing step is shown. This is quite important to know if you write scripts, because if you write script and you always print everything to the command window, so the result of each step, and if you have millions of entries in your matrix, then it will cost a lot of time because everything is plotted. Therefore, you should always use this semicolon version. Only if you want to see the result. Only in this case, you should use it without the semicolon. So, therefore, this is the debugging version, I would say, and this is the normal program version. So what you have here now is a 1x1 matrix. So if I do this, and if I call it, you will see that it's a 1x1 matrix. So we will get this field, and here in this field, you have one element set, so 1x1 with 25. Okay? So if you do a calculation, you can now just enter your calculation like known in math. So 2 plus 3 is 5. If you don't assign a special memory variable, so if you don't assign an identifier, then all of the results will be stored in ans for answer. So if you calculate 2 plus 3, then the result will be stored in answer. If you do it with a semicolon, you won't see the output. But of course, there is a matrix, a scalar matrix, available in the workspace where your answer is stored. In this case, 5 here. So you have now the possibility to do calculations, and you know that you can give own namings. You should always think about how you do your naming. There are 2 versions which I use in different styles. The first one is called camel case, because the naming or the name looks like a camelback. You always use uppercase for a new logical word like num or number of students. So you see that the N and the O and the S is uppercase and the rest is lowercase. So it's camel case, like a camel back. And therefore, you can identify the different logical combinations. It's up to you. It's optional how you name it. So you can define your names. But I would suggest that you always give names which are understandable, so that after a week or after a month or after a year, you still know what this variable contains or what this matrix contains. The second version you have already seen is with this underscore. So if I write it this, I can write everything with lowercase number of students, and I separate all of the words with underscore. It's up to you how you want to use it. I prefer the first version, this camel case, which is also an ANSI style. But it's up to you. But you should always give unique names. You should take care that uppercase and lowercase is separated. So if you have number of students equal 25. So this and this, so this upper lowercase mixture and this lowercase mixture are 2 different variables. These are the first errors what you will have, that you create a variable and you type it again and you have typos, or you use it in the wrong uppercase lowercase structure. So remember, if Matlab tells you that there is an error, remember that it might be the case that you typed the variable name wrong. So let's switch to the next slide. Variables are always specified like in math, and if you want to use power of something, or in special case power of 10, then you can use this E letter. So like here, 3e 5 or something like that, then you have the power of 10, so 6.02252 e23 means 6 to the power of 6 times 10 to the power of 23. So as I already said, floating point numbers are always in double precision. So you have about 16 significant decimal digits, plus 2 or 3 more, which are hidden. And therefore you have a range between these numbers, roughly between these numbers. So let's come to the next matrix version. So we already have seen scalar, scalar number of students. But how can we create vectors and matrices? So let's switch to Matlab version. And let's clean our command window. So if we create a scalar, we have already seen, for example, a equal 1. Then you have a scalar or a scalar matrix 1 cross 1 elements with the value 1. If you want to create a a matrix or a vector, then you have used the square brackets. For example, if I create a vector, I can do this: 1, 2, 3, 4, 5. So I use the square brackets, which tells me that now a vector starts. And if you separate it with a white space, then it's a row vector. The same can be done if you use commas here instead of the white space. Then you will get a row vector. If you want a column vector, then you can use, instead of the commas or instead of the white spaces, a semicolon, and then you will get a column vector. And of course you can transpose one into the other. So if you have the column vector and you transpose it, then you get a line vector or a row vector. So this transpose line, this apostrophe, single apostrophe, can be used in this case. As you see here, if I do not do an assignment, I get the result in answer again. So if I want that the result should be in the vector, then I write A equal A transpose, and then I will get the result in the vector A. So always remember this. If you want it in your own named matrix, then you always have to use this. And matrices in principle are combinations of row or column vectors. So you should already know the difference. The difference is a comma or white space and a semicolon. So it's quite simple to create a matrix. Let's CLC and clear all of this stuff so that we have a clean environment again. And then if you want to create a matrix, or let's say my matrix, then you use the square bracket and you write a row vector, and then you continue in the next line and you write the second row vector with the same dimensions, though they must be always well distributed, so well populated, so the dimensions must fit. If you forget one of these dimensions, so for example, if you just enter 4 elements, then you will get an error. So I'll show it to you. In this case, it's correct, so you'll see the matrix. And for example, if I forget this, have you seen? I got the previous command with a arrow up or arrow down. So with this, I can scroll. I can scroll through the different versions. And if I do this, I will get an error that the dimensions do not fit. So therefore, I have to use the other version, so which is correct with the correct dimensions. So here is the matrix. If I want to plot the matrix in this way, I just have to enter matrix and I will see the result. Or I can also use another function which you will see later, this display function, my matrix, where you just will see the values of the matrix. So disp means display, and it just represents the value of the matrix. So you have seen this, that you get a matrix, and very important is that you now can select different indexes in this matrix. So let's jump back to Matlab. Let's clean up our command window and let's create my vector. 1, 2, 3, 4, 5. So now we have a matrix and a vector. The vector is a row vector or line vector with 5 elements, and the matrix is a matrix with 3 cross 5 elements. So if you now want, let's print the matrix as well, my matrix. So if you now want to get exactly this value, then you can use this selector version, so that you have an index of this dimension and an index for that dimension. And you can do it by this. You use my matrix, which is the name of the matrix, and then you select the line or the row, and with the next one you select the column. So let's say we want to select the 9 here, so we want to select the version here. So we have to go into the second line, which means 2, and then we say comma, and then we have to go to the 1, 2, 3, 4th column. Again, we start with index 1, so different to other languages. So therefore, this is the second line, and this is the 4th column. So if we do this, we just get the value there. The same can be done with vector. So my vector equal, not equal, sorry, for example, index 3, and then we get the value of index 3. So it's always quite nice if you create a matrix like this manually. Often you have matrices or vectors which are in a way that you have a continuous sequence of values. So for example, a vector from 1 to 10, or a matrix which counts all values, and so on. So it's quite helpful if you have an operator doing that, and especially, for example, if you want to select the first 3 rows and the first second columns. And therefore, Matlab offers you the colon operator. So this colon operator can be used to do selections of sequences and to create sequences. So let's do this. Let's clean up again, clear all, so that we have again a clean environment. And then let's start with this colon operator. So if you want a vector which counts from 1 to 10, then you can create vector equal, and then you can use this colon operator. It starts from 1 and counts to 10. If you use it in this way, you have always an iteration step of 1. So the first is 1 and the next is 1 higher. So here's 1 plus 1 is 2, plus 1 is 3, and so on. So if you want another iteration step, you can use the version with a double colon. So where in the middle of these 2 columns, you can define your iteration step. For example, 2. So if you do this, we start with 1, it's here. The next step is 2 higher, so 1 plus 2 is 3, plus 2 is 5, plus 2 is 7, and so on. You can use this also to count downward. So for example, if you have from 10 to 1, you have to use this version. So the iteration step is -1, and then you will start from 10 and you count down -1 9, -1 8, -1 7, and so on. Or you can also use an iteration step which is a fraction of a floating point number. For example, if we want 0.5 as iteration step, so we'll get 1, 1.5, 2, 2.53, 3.5. So we use 1 colon 0.5 colon 10. So this is quite helpful to create such simple sequences of numbers. Much more important is it for the selection of values in a matrix. So let's fetch back our matrix. So I use the arrow key and I will create my matrix again, just fetching it, or just fetching my command, and then restart it again. So I have the matrix again available. And now let's say I want to select a submatrix just of the first 3 columns and the first 2 lines. So the matrix should contain, the new matrix should contain this. Then you can use my matrix with the index selection, and now you say again the lines which you want to select and then the rows which you want to select. So you have from 1 to 2 and from index 1 to index 3. It's not the value here. So these what you see here are the values, not the indexes. I just used the same values than what you see in the indexes, so that you have it a little bit easier to select a specific thing. But the matrix value can have any value, or the matrix position here can have any value, but it always has the index 1, 1 here, and this is always the index 1, 2, and so on. Okay, so if you do this, we'll get a new matrix, which is just a submatrix of this. So with this, we can select anything, for example, just the last 4 elements. So we do the same again. So we start at the second line, go to the third one, and we start at the 4th row, 4th column, and end in the 5th one. So what we should get is now this. You see, in this case it's quite simple to know how big the matrix is, so to know the end indexes. But if you have large matrices, it's quite difficult to find this, and therefore you can use a reserved word for the end of the matrix. So in this case, you can use end, and if you do this 2 to end, 4 to end, then you will also get this version. And you can also use this end like it would be a normal variable, because, for example, if you want to select the last 2 columns and the last 2 rows, then you have to know here the relative position. So therefore, let's fetch the command again, and we use end -2 and end -2 here, so that we get the last 3 values, or end -1 and end -1, so that we get the last 2 values per column and row. So you see, it's a really powerful tool. You don't have to know the exact dimensions of the matrix, and you can select quite easily single elements of this matrix. So let's jump to the slide to repeat the things. So we learned about the colon operator. The colon operator can be used to create something like continuous sequences of vectors or matrices. You also can define the step size or the increment size. So if you use 2 columns, we also can use it for calculation from top to down, so that we start by a higher number and count to a lower number. So all of these things are possible. We use this especially for the selection mechanism by indexes to the matrices, and therefore we can use these things to select specific parts. We use it also for the end dimension. So if you don't know how big this matrix is, then we can use it. So, and here are two other things which I can show to you. So if you want the complete row or the complete column, or if you want to replace a row or a column, then you can use this as well. So let's go to the Matlab. We have the matrix I first clean up so that you see better my matrix. So we have this matrix, and then, for example, we want to select the complete second row. So we have different possibilities. We already know that we can use my matrix, brace open, second row, and then we want to select the complete row, so from 1 to end. So to simplify the life, Matlab also offers you a shortcut for this. So if you use it without any parameters, so if you use the colon operator without any parameter, you will get also the complete row. So it's a complete counter through all of the columns. With this, you can also now change positions in the matrix. So for example, if you want to change the first value in the matrix, so we want to replace the 1 by 150, for example. So we select my matrix, first row, first column, and it should be now 150. So if I now print the matrix, you see that the 1 changed to 150. So if we want to replace the first 3 elements in this row, we can now use this selector. So what we do is we select my matrix, and we now want to replace the complete row, but only the first 3 elements. So we use 1, 2, 3, and now we set a vector. It's a line vector, so it's a row vector, and therefore we replace 120, 130, 140. And then if I print the matrix again, you see the first 3 values here changed. So this colon operator, or how I say the selector mechanisms, are really, really powerful. So you can manipulate the matrix in various sceneries. It's quite helpful if you do this. And you can also create matrices in different ways like this. So you can combine matrices from existing matrices. For example, if you have a matrix with a lot of different data, so that each column is another data set or another value type, then you can select only the values. For example, in our project, we have 8 columns representing one sensor, and if we just want to get the speed values of all sensors, we can select always the complete column for each sensor where the speed is located. So this is quite helpful to shrink the data, or to use one big matrix and just select what you need from this matrix. So therefore we can come back to the presentation. When you can select, then you can also combine new matrices. So if we have a matrix, we can use these selector mechanisms to select small pieces, and then we can combine with these pieces new matrices, or we can delete a complete line and things like that. So let's have a look to that in Matlab. I clean up again, and I print my matrix again. And then, for example, I want to delete the second complete row. So I can use an empty vector, which I assign to the position. So my matrix and it's the second line. So the second line, the complete line, should be now empty, which means, or should be deleted, which means I assign a complete empty vector. And what you get now is a new matrix where only the first and the second row is given. So, question, delete the fourth column. What will you do? So the fourth column is here. So try on your own computer to delete the fourth column. You know, it's again quite simple. So we want to delete the complete column. So we want to delete all rows in this column, and we want to delete the fourth one. What is not possible is that I delete just this element. So for example, the second line and the fourth column cannot be deleted. Why? Because then we would lose our well-distributed dimensions. So we will have no matrix anymore with 4 cross 2, 2 cross 4 elements, and therefore it cannot work like this. So if I want to create a new matrix, my new matrix, I can assign parts of the old matrix. For example, if the new matrix should just contain the first and the second column, then I can create a new matrix. You remember, matrix is always, or vector is always created with square brackets. Then I use my matrix. I select the complete first row, and with the column index 1, I add this in form of row vector, because it's the next column. So my matrix completely the third one, and if I close this with the square brackets, I have a new matrix, my new matrix, which just contains the first column and the third column, for example, in this case. So you see, you can use selected parts of a matrix to create a new matrix, and this is also quite helpful. So you can, for example, cut off pieces, and you can rearrange it to a new matrix. So for example, let's do, so we still have my matrix, and then we want to enter a new line in between of this line. So for example, my matrix should now be a new matrix, where I take from my matrix the first line completely. Then I go to the next line where I enter a new vector. So for example, 1, 2, 3, 4, the dimension must fit again. Then I go to the next line and I enter the rest of my matrix. And here I can do the following to the end. So if I don't know how large the matrix is, and I enter all parts of the matrix. So if I do this, you will get a new matrix in my matrix. So I arrange these pieces and extend the matrix and store it again in my matrix, so that I have the first line, a new line, which I defined here, and the rest of the matrix. And with this, you can cut off pieces, you can combine pieces of a matrix with a new one, and you have all of these possibilities available. what you have to do now is you have to play with this. So try to write your own matrices, try to write your own vectors, and then select different values. So you should be very used to these selection mechanisms, because this is one essential part of Matlab. And it's very, very helpful to have this colon operator, and you can improve your code quite tremendously if you deal with this stuff, because usually in other languages you have to write loops for that. So you have to write your own mechanism to go step by step from one to another element. And therefore it's quite difficult and large program to get this stuff. Here you just have one line, and one line creates a complete new matrix with a new combination of values. So this is a really powerful tool what you should use. Okay, so we have now numbers, matrices, vectors, things like that. But of course we want to use also text outputs, or we want to also create text with our program. You already saw disp and then brace open, singles, colon, and or single apostrophe, and then hello world, which printed hello world to the output. So you have already seen this. So it must be something like text. So these single quotes identify text. So let's go to this. A text is represented with a single quote. Single quote at the beginning, single quote at the end. So it's nothing else than the square bracket, or the square bracket use. You have to use the same quote. So the beginning quote and the end quote is the same. You see it here. And in principle, a text is nothing more than a vector. So I want to show it. Let's clean up, clear all, and we create our text. So text equal hello is our text message. So if I open it, you now see that there is now character, and if I open it, you see that it's one block with hello. So it's the text character. But in principle, what you have here is nothing more than a vector. So you can select each single element. For example, with text 1, you will get the H. With text 3, you will get the L, and so on. And the nice thing is also that the text is based on the ASCII standard. So it follows the ASCII table. So each character, each key which you hit on your keyboard is based on the ASCII table. And it means that you have a coding standard which converts the sign you can read, the alphanumeric sign, to a binary representation. A binary representation which can be converted to a decimal number. So I show the ASCII table here. So ASCII table is nothing more than a setup of different characters. For example, if we watch the uppercase A, we are here, and the uppercase A is the binary code which can be converted to 65 in decimal. So it's nothing else that we count through the table, and we have special positions. So A is on position 66 because we start with 0. We have control signs at the beginning up to 32, and the real signs start with number 33. And then we have uppercase and lowercase letters. And therefore, these vectors can be used for calculation as well. So, for example, if I want to show you the ASCII numbers, then I can do text plus 0. So text is the character string, plus 0 calculates a 0 number to all of these values, and then you'll get the ASCII numbers, so the decimal numbers of the from the ASCII table. So, and with this you can also do some manipulations. For example, I can go to the next position. So text plus 1 is the next position, and if I convert it back to character, and here's the function character char. By the way, it's quite interesting what I did not explain here. So if you want to know what the different functions offers to you, so what you can hand over as an argument to this function, we come later to functions in the next lesson. But here, if you just enter the command and you wait a little bit, it will give you a suggestion of possibilities. So we enter now text plus 1 here. So we use text, convert it to the ASCII numbers, then we add 1 and we convert it back to character. Then you will get always the next letter. So I is the next letter in the alphabet after H, F is the next letter after E, and so on. And there is a nice example which I can show you here. Maybe you know the film Odyssey 2001. It's an old film, so a classic film. And there's some guesses that the name of the computer who takes over the control of a space station has something to do with one huge company in our human life. So in the days as the film was made, so one company was very, very important, and people had some fears that they will take over or rule the world, and therefore it was coded in the film. There's just guesses that it is like this, but the computer in the film had the name HAL. So, and if you have this computer name, you can find out which company was in the critic to be the most important one and might rule the world. If you just do the following character conversion, we already know computer plus 1, and if you do this, you will see which company it was. You should do it yourself. Okay, so it's quite nice that you play with this. For example, you can also calculate the distance between uppercase and lowercase, or lowercase and uppercase in this, because the lowercase is in a higher index in the ASCII table than the lowercase. So if I do this, I know that from uppercase to lowercase I have 32 elements, and I can use this for calculation. For example, if I want to convert the B lowercase to uppercase, then I have just to subtract the distance between uppercase and lowercase, and I have to convert it back to character. So what I get is uppercase B. So it's quite nice to do this. Also, if I have numbers, I can convert to a real number, because if you have the letter 0 or the letter, let's say the letter 9, So then it's a letter. It's not the number, it's just the letter or the character for 9. But if I want the number 9, then I just have to calculate -0, for example. Minus letter 0. And then I get the number 9. So there is now a difference between this answer and this answer. You see it? Here we have these single quotes. Here we have just a number. So this is really the numeric number, and this is the character in the ASCII table. So if you want to see the differences between numeric and ASCII table, let me know. I can make another video where it is shown. So it's just playing a little bit with character codes, and it's decimal or binary representations. Let's come back to the lesson. We now know how we create some versions of matrices and some versions of, let's say, vectors. And what we want to do is we want to calculate with this stuff, and therefore you need operators. So these operators are the usual operators you know from math, and you see they are here: the addition, the subtraction, the multiplication, the division. And then you have, because it's matrix operation, you have the left division, you have power of, and you have the complex conjugated transpose. So this is this apostrophe or this single quote, and you have special evaluation order, so that you can quote your equation parts, your terms, so that you can arrange evaluation order. Okay, so what you see here are matrix operations. For the addition, it doesn't matter. For the subtraction, it also does not matter. But for the multiplication, it matters. So if you have a matrix multiplication, it's a matrix multiplication and not a normal multiplication. And therefore, you have the possibility to also select another form of multiplication or division. And this is the element by element division or multiplication. So you can do the matrix multiplication or an element by element multiplication. And what is exactly the difference, I want to show you with a small separate sample. So the following sketches should show you how the differences are between matrix multiplication and element by element multiplication. So let's take two vectors, a row vector and a column vector with 5 elements. And what you do if you do the vector multiplication, you take the individual position, so index 1 of vector 1, index 1 of vector 2, you multiply these two values, and then you do it for each position, and you sum the results up to get the final result. So what you need is a row vector and a column vector, and it will result in a scalar. So therefore the dimensions must fit to get at least then the scalar. So for a matrix, it's the same principle here, in this case a 4x4 matrix. So the dimension must fit again, and what you do is you multiply the individual according positions. So for the vector in row direction and the vector in column direction, and then you sum it up to get the first element, and you do the same for the second element. So this vector multiplied by this vector, and you get the next result. So if you do this for all, you will result in a 4x4 matrix. So as I said, the dimension must fit, and then you have the classic matrix multiplication. This matrix multiplication is always done if you don't use this dot operator. So if you use normal multiplication sign, then you have this classic matrix multiplication. The difference to the element by element multiplication for simple vectors, it's quite clear. So you have two row vectors, and you take always the individual values of the individual indexes. So, for example, position 1, both values for position 1 result in a new value. So you multiply the value of index 1 with the value of index 1 of the second vector, and then you get the result. And you do this index by index, and it will result in a vector which has the same dimension like the original vectors. So, but what happens if you have a row and a column vector? Then the element by element multiplication works in the same style. So you do a multiplication of the index values, and you result in a first value. Then you do it for the second, you result in a second value, and so on, so that you get first complete column, and then you do the same for the second column. So it will result in this case 5 cross 5 matrix, where each column vector has the multiplication of the scalar with the vector. So therefore it's an element by element multiplication is completely different to what you get with a classic matrix or vector multiplication. So let's have a look onto the multiplication done on the matrix. So it's again an element by element multiplication, so the result should be clear. So you take this, and you will get the result. You take this, and you get the next result. So what you get is again a 4 cross 4 matrix, but now the elements that do not contain the multiplication of the vectors, it contains the multiplication of the single elements. So it's a totally different result than what we got before with a matrix multiplication. And this multiplication is always done if you use the dot operator. So dot multiplication sign will always do this element by element multiplication. So you now know the difference between the multiplications. So for example, if we go to this multiplication dot, this is an element by element multiplication. If we go to a slide previous, so this multiplication here is the matrix multiplication. So you will get different results for the different multiplications, and therefore you should now be able to calculate this here. So if you watch this, we create a vector, and then we calculate the power ofs with power of 2. So do it and interpret the result here. With this, we have everything what we need for the basic operations. So we can do simple calculations, we can select matrices, we can create matrices, we can manipulate matrices, we can do a lot of this stuff. And therefore we have a lot of things available at the moment. And the next steps deal with higher level functions. So let's have a look into these additional functions directly offered by Matlab. Matlab gives you a lot of additional functions without an additional package or toolbox what you need. So there are different types. They are classified in different groups. So for example, desktop tools and development environment, then mathematics like linear algebra, data analysis, or things like that. So then programming data types, file input output mechanisms, graphics, 3D graphics, or graphical user interface, so application interface, and you can also have external interfaces so that you can call functions from other languages, for example. So it's a really powerful tool. I cannot show you all of them, so you have to search a little bit. If you have a special challenge or a special problem, then search if there is already a function which you can use. So if you go into the mathematical functions, then you can split it into arrays and matrices, linear algebra, elementary math, data analysis, polynomials, interpolation things, coordinate system conversion, nonlinear numerical methods, and. Or you have these math constants, which we all have already seen. So again, remember, Matlab always represents the things as functions. So you have no constants like in other languages. These constants are calls of functions. So if you call pi, then a function call is done. For you, it doesn't matter because you won't see it, but in principle, it's a function call. What I want to show you now are the most important functions for our project. Simple, basic functions which you can use here. So therefore, I directly switch back to Matlab. And you know what we do? We make clear all and CLC so that we have a virgin environment. So let's create a matrix again. Matrix A equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So with this matrix, we can now show the most important functions. For example, we can sum up the matrix. So if we call sum, in this case, it always sums up the columns. So therefore, you will get 11 plus 6 is 17 plus 1 is 18. Or in this case, 12 plus 7 plus 2 is 21. So if you want to sum up the complete matrix, you can do this, which directly shows that you can call functions in a nested way. So you can use the matrix, hand it over as argument to the first function call, and then the result can be handed over to the next function call. And then if you do this, you get the sum of all elements or of all values in the original matrix. So therefore, you can write one line of code and it can do a lot of things inside there. Another important function is the diagonal. So let's clean. We have again the matrix A. So if we just want the diagonal, then we use diag A and we get the diagonal. So in this case, we have a matrix which is not equally dimensioned, and therefore we get the diagonal in the equal dimension. So here in 3 cross 3, and therefore you see 1, 7, 13. Another function is the flip. There are two the flip functions. So there are two flip functions, left, right, and up, down. So again, we have the matrix A, and if we want to flip the matrix up, down, then we call flip up, down of matrix A. You see, it's always the same style. You have the function name. These function name are predefined reserved words. And then you have brace open, brace close. So these parentheses contain the arguments which you want to hand over, and then the function returns the result. So you can say, for example, a flipped, which is a new matrix, and you assign the result of the flip up down of A to this matrix. So this is always the classic mathematical call. So you have a handover argument in this parenthesis, you call this special function, and then you return a value which you can assign again to another. We also can flip left right, so flip up down is clear. So you have now the first line in the last position and the last line in the first position. So flip left right should also be clear then. Let's clean again, matrix A, and then we do flip left right A, and then you see that the right part is now on the left and the left part is now on the right. Quite often you have to know the length of the matrix, so it means the size or dimensions of the matrix, and therefore you have two functions available. One is more used for the vector situation, and another is used for the dimensions in matrices. You already know the end. End is usable in the selector mechanisms where you use indexes and the end or the last index with end. But if you want to know which size this matrix has, you can call size of matrix A, and then you will see that it is a matrix 3 cross 5. So the answer is a vector, and the vector contains in the first position the number of rows, and in the second position the number of columns. And of course, if you assign this again to a new vector name, dimensions equal size of A, then you can use this as a selector. For example, if you call A matrix from 1 to dimension 1 and all columns, then you will get a correction. It's quite nice to show you that also that there is an error because what I did is what I explained, that I used a wrong name. So I created dimensions and I used a dimension, and therefore Matlab tells you that there is an error, so dimension, and it automatically suggests the dimensions. Okay? So with this, we have 1 to end, and here also 1 to end. So therefore, this replaces the end in this selector. So we have these dimensions available here. So it's often used in loops. If you want to count from 1 to the maximum of indexes, you can do it with this dimension selection using size. Another method is used for vectors mainly, so which is called length. And if you do it on the matrix, you will get the length of the first vector in the matrix. So you will get the dimension for the number of columns. Okay? So if you do it for a vector, then you will get the length of the vector. So these are these functions. There are some more. I directly show it again on the screen of Matlab. So let's clean and CLC. So if we want to create a matrix which contains just zeros, then we can do this. Set, or our own optional name, is zeros with, for example, 10 across 10 elements. So don't forget that this is an argument here for the function. It's not like in the vectors or in the matrix, so that this is a separator between columns or lines or something like that. So it's a call of the function. If you have two arguments, then you have to separate these two arguments with a comma. So if you do this, you will get a matrix which contains zeros. This function is very, very important. So why is it so important? It optimizes the runtime of your program. So if you do the following, I will show it directly here then, that you create a matrix step by step. So for example, you take an existing matrix and you add an additional line to this matrix. The matrix must be rearranged, which causes a lot of memory access, because the old matrix will be copied to a new position in the memory, which is extended. Then you copy your new vector onto this position, and then you delete the old. And therefore, this is really, really connected to high costs in time. And therefore, to optimize your program, it's much better if you know how big or which size the resulting matrix should have. If you create this size and then you just replace the values, because then you do not have the rearrangement of the memory all the time. So it's much better instead of doing this. So for example, if we have this matrix set and we want to add a new line to this, that we do this set with a new line. This is really memory intensive and cost intensive, therefore, because we take this, which is already in the memory, we create a new memory with an extended allocation of memory, and then we set it. So it's much better, instead of doing this, that you create the matrix already with this size, and then you just set the right position. So for example, you use set, lowercase, position 11, and first value, for example, and replace it. Okay, so therefore it's much less intensive to do it in this way, instead of always rearrange your memories. And therefore this function zeros is really, really important. Always create your memory first and then just set the values. Of course, you can also set the values to ones, so that everything is ones, is filled with ones. So there's a function called ones. Is for this memory consumption, it's the same. It doesn't matter with which value you set it or initialize it, so it's the same. There are also two functions which create randomized values. It's just for completion here, so we don't use it. If you call rand, you will get a randomized value matrix. Much more important than this is the function a. So if we create the function, if we create a matrix with the function a, then we can define the dimension. A is always an equally dimensioned matrix. So for example, if we define 5, then we get a matrix with 5 cross 5 elements, and on the diagonal, we have just ones. So do you remember how we get the diagonal? Sure. Diag set. So here we have the ones. Okay. So I won't focus too much onto this function, because I might experience that if you need a special function, you have to search it, and then you have to find out which arguments are possible, and then you use it. I just want to mention different functions here. So we will deal with sum, we'll deal maybe with sort, with mean and max, of course, with mean, because this is the arithmetic mean, so the average or mean value. And these are the functions which we will use much often. There are much more functions, especially for the descriptive statistics, where you can also use not a number if you have no value for this data set. And then you can also find out where these special values are, or you can find out where numbers are which are greater than a special number. So you get the indexes. You have the function is finite, is not a number, or is infinite. And if you have the values here available, like not a number, then you will get a 1 at the position where this not a number is located. For example, here in this case, we have done the 1, 2, 3, 4, 5th position, and then you will get, if you call is not a number, you will get a 1, 2, 3, 4, at the 5th position, a 1. Okay. You have also the function find. Find is really powerful. It will give you the indexes where this is true. So, for example, if you search the indexes of not a number, then it's position 5 and it's position 12. So you should keep also this in mind. I want to show you another method where you can use selectors. Let's jump back to the Matlab, and I want to create again a matrix. Let's clean up. So let's create the matrix again. 11, 12, 13, 14, 15. So this is my matrix. And if I want to get all values which are greater than 8, for example, I can use a selector where I write my condition into this selection sequence. So do you remember that we used it here for indexes? We can also use it for a condition here where we use the same name of the matrix. So here A is greater than 8. So it tells us that all values which are greater than 8 are shown now. And then you will get 11, 12, 13, 9, 14, 10, 15. And then you can sort them. So it goes through the whole matrix and gives you all values which are greater than a special value, or greater, equal, or lower. So these selector mechanisms are also really powerful. Or you use this find mechanism and then arrange the indexes according to what you need. And with this, you can also find outliers. You can think about if you use it for the motorway data, but it's always a special manipulation in the data. So therefore, you should think about if you have outliers. So for example, if the sensor fails or something like that. But you can, of course, use the sigma criterion. So here with this, you can use this different set of functions. So you can use the standard deviation, mean calculation, absolute function, and then you use the find function to find where the outlier is located, and you will get back the index of the outlier. So this is this sigma criterion calculation to define outliers, and it's just for completeness here, so you should know it for maybe other projects. More important for us is plotting. And therefore we go to the final few slides where I want to show the basic plot mechanisms. Much more you will see during the practical training then, but here you should get a first, let's say, view onto what is possible. I directly want to show it with Matlab. So let's clean everything. And then let's start with a simple plot. So in the slides you'll find this plot mechanism. You should already know what I do here. Do you know what this function, what this call does? Correct. So we start from 0 and end at 2 pi. And we will do with a step size or iteration step of pi over 100. And there we will get a vector with steps from 0 to 2 pi, which you can use to plot, for example, a sinus or a cosinus. So we can calculate the sinus if we use the previous x vector. So we created this x vector and we hand it over to sinus. So what we get is, for each x value, we will get now a y value, which is the sinus for this x value. So for the plotting, we need exactly the same vector sizes, and then we can plot y over x. And this is done with the function plot x comma y. And then we will get a nice plot which shows in a figure the sinus function. Okay? We can also label the axis so that we use x label and we write the text for the x-axis. So for example, x equal 0 pi. Okay. And y label sine of x. And if you watch the graph now, you see that x goes from 0 to pi. Oh, I should have written 2 pi, sorry. So let's change it. 2 pi. You see? And here's sine of x. And if we want to set a title, plot of the sine function. So you directly see the title. You can also set the style of the output of these texts. For example, if you want to define the font size, you always have some reserved words which represent special parameters of outputs. For example, in this case, we can define font size and define the size of the font in pixel. So it changes to a different font size. Or if we do 18, then you should see it. Okay. So therefore you can change the color or you can change other properties, and you identify the properties with these unique reserved words. If you plot it again, for example, if you call the plot here again, then it will be overwritten. So we lose the title and the X and Y labels. So if we want to plot more than one graph into one window, then we have to use plot in a different way. So let's create different graphs. Let's say the first one is the Y, which is the sinus of X. The second one is Y2, which is a shifted sinus of X minus 0.25. And then we have a Y3, which is shifted by 0.5. So now we have three different graphs, and we can plot this now with tuples, always with X and Y. So this we already know. And now we can directly plot the second one and the third one. And if we do this, we should see three different graphs. If you don't want to plot it in one thing, in one step, sometimes it's not possible if you do it iteratively. For example, if you have a loop and you do it iteratively, that you add new data and things like that, then you can do it also step by step. So let's do the plot as it was. So we lost the information. And then you can use hold on, which keeps the current output for the next outputs, and then you can plot XY so that it plots the second one, and you can plot Y3. And if you don't want to plot anymore into this same window, then you write hold off. You can also select the window in which it should be plotted. So for example, you can create three different figures. So for example, you write figure 1, and then you plot to figure 1. You see? If you create figure 2, it creates a new figure, and then you can plot to figure 2, the second one, so that you now have two different figures with a different outputs. You see? Figure 1 and figure 2. Let's create again everything into one plot. If you want to explain the three different outputs, you can add a legend to that. So you write legend, it's a function again, and then you add just the names of the three different functions, or the outputs of the three different functions. For example, sine x, it's up to you what you write here. It just arrange that the first plot is this name, and the next plot is that name. So the next plot is sinus of x minus 0.5, and the next plot is sinus x minus 0.5. So that's correct. And if you do this, it will write a legend to this plot, which explains the different colors in your output. So let's jump back to the presentation. You'll find everything there as well. So here's the simple plot, and here is the next plot version, which I explained before. What you also can do is now, if you don't want the automatically selected colors, for example, if you have different windows, different figures, then always the color is the first automatically selected one, which is blue in my case here. If you don't want this, so if you want to define your own colors, then you can set it. You can set it with RGB codes, or you can use predefined strings, like these color strings. C means cyan, M means magenta, Y means yellow, and so on. The only difference which you cannot directly find out from the first letter of the color is black, because blue is already related to B, and therefore black is related to K. So if you want to plot in black color, then you have to use K. Then you can also select the line style, so you can have solid, dashed, or dotted, or dash dotted style, and you can also set some markers so that the values are represented with a plus or a O, which is a small ring, or an asterisk, or an X. There are different others, so I want to show it to you here in Matlab so that you directly see what happens. So if you want to plot, for example, the first graph with magenta, we can do like this, and then we'll get a magenta version. So if you want it dash dotted, you do it like this, and then you will see that it changes to a dash dotted version. And therefore you can select for each output an individual color, for example yellow and dotted, and here green and dashed. And what you get at the end is this. With this, you can plot really nice outputs, and you have a lot of possibilities more. To complete it here, I just want to show that you can also plot a logarithmic graph, or you can do a plotting of complex data. So I won't explain it here in detail. It's just that you know that there are a lot of possibilities which you can directly use without any additional package. So in other languages you have to write a lot of program code to get the same output. Quite nice in Matlab is the plotting of three-dimensional functions. So let's directly do it with Matlab again. Let's clean up this stuff, and then let's create a vector with 50 steps up to 10 pi, and then we can plot in 3D. So plot plots in 3D, the sinus, for example, of t, and the cosinus of t and t. So it will produce a really nice graph. It's a spiral, because now we have 3 dimensions. The first one is the sinus, the second one is the cosinus, and the third one is t. So you can play with this a little bit. For example, if you create a x-axis from 1 to 10, a y-axis from 10 to 1, and another vector I forgot the minus each time. So if we calculate from 10 to 1, and then if you create a set vector with the same number of values, of course, which starts from 1, 2, 3, 4, 5, 4, 3, 2, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. And then you can use this for plotting. For example, you can plot 3 x, y, z, and if you watch this, you can create a really nice three-dimensional plot. And for example, if you plot xx, then you have it in the other direction. And remember, if you make hold on and we plot this again, hold off, then you can plot the two outputs into the same diagram. And there are some additional menus which you can have here. You can store it as an image, or you can also rotate so that you can dynamically search the view angle. This can also be done with some settings for the graph in the program. So you have a lot of additional possibilities to set the properties for this graph. It should just demonstrate what is possible. Other really nice tools are, for example, mesh and surface. So if we create a cylinder, we use this t vector which we created before. So now we create a cylinder with x, y, and z value. Cylinder which is 4 times cosine of t, the t vector we have before. Then we have a cylinder, and then we can draw mesh, which is x, y, z, and then we'll really get a nice mesh plot here, you see, which you can rotate. And if you use surface, then you get it with a closed surface. So now the single parts are colored. Okay, each region is colored now, and you see it's really a nice tool. You can turn it, watch it from down or from up, and it's really cool. You can define the color map and plot the color bar so that you will get information inside there. So we changed the color map to another one, so they are predefined color maps, or you can create your own color map according to red, green, blue colors. Maybe we'll see it during the different sessions and lessons. It should be just a first introduction and a first view onto what is possible. So, and with this, you can also create different outputs. For example, a mesh grid, surface mesh or contour plot, or a color plot. So you have a lot of possibilities of three-dimensional outputs. Here you see them in different styles. The difference again is if you have surface, then you have it here available, that all different areas are colored, and here you have just a grid, which is just a mesh, or here there is the isolines, a top view onto this three-dimensional plot, so that you have a contour plot. So finally, we have already seen that you can select different figure outputs. So selecting figure 1, figure 2, and so on. You can also plot into one plot, so that the first output is in a first square a section of the window, and the next one is in a next square section. And what you should know here is that it is like a matrix again. It is done with subplot. So subplot defines the number of plots in x and in y dimension. So this is the x dimension, and this is the y dimension, and then this is the number of the plot. So you have a 2 cross 2 output, and the first plot is this, the second plot is that, the third plot is that, and the fourth plot is that. So the first, second, third, and fourth. And you see the different outputs in one window. And this is quite helpful. For example, we will use it for the raw data. So you can plot all sensors in one window so that you see the differences according to the sensors. And you can manipulate these outputs. Also during the project, you will learn how to change these properties. So if you want to see the properties of the current window, what you can change, then you make set get current figure, and then you see all of the possibilities which you can manipulate and which you can set. So you always can get a handle for individual window or for individual property, and then you can manipulate this with GCF, which means get current figure. You get the current handle of the current figure, and with this you can manipulate all of these things, and you can also individually define your outputs and styles and so on. So with this, I want to finish my first lesson. This first lesson, or this first video, is longer than the usual videos, because usually these are 2 lessons, but we will split it into this theoretical lesson based on the video, and next time we will have a practical lesson using Zoom. So therefore, I want to say stay safe, and we'll see each other for the next lesson. Bye bye.